Alright, I think I'm going to make this one the last one for the day. This is question number 15, module number 7. A researcher claims that the stomach of blue crabs from location A contain more fish. As soon as I read that, I'm going to go ahead and type up my hypothesis. So, location A contains more fish. So, what they are saying is that mu of 1. Oh, I meant to put the Greek symbol mu. That mu of 1 is what? Greater than mu of 2, right? And I'm making that an alternative hypothesis because when they say more, they're not saying more than or equal to. They're just saying strictly greater than. So our alternative hypothesis is going to be mu1 is greater than mu2, and the null hypothesis will be that mu1 is less than mu2. Now imagine this for me. We can subtract mu2 from both sides. If I subtract mu2 from both sides, what will happen is the left-hand side will become mu1 minus mu2, and the right-hand side will be mu2 minus mu2, which is 0. I can do the same thing over here, subtract mu2 from both sides. So the left-hand side will be mu1 minus mu2, the right-hand side will be 0. Those are the hypotheses that we are testing for this problem. So, identify the null and the alternative hypothesis. Null is assuming that mu1 minus mu2 is less than or equal to 0, and the alternative is assuming that mu1 minus mu2 is greater than 0. Alright, let's find the standardized test statistic for mu1 minus mu2. I'm going to go ahead and use StatCrunch to do that. I think this is going with the p-value method, so I will go ahead and open up stat. And I have to decide, are we using z-stat or t-stat? And of course, that depends on do we have a population standard deviation or not. Let's read. The stomach content of sample of 13 blue crabs from location A contains a mean of 198 milligrams. Now, I want to know about standard deviation. Now, this part, they gave us standard deviation, but this is the standard deviation from this sample of 13 crabs. So that is not population standard deviation, that is sample standard deviation. That's not what I want. The stomach content of a sample of 9 blue crab, blah, blah, blah. You know what I'm looking for, right? I read it, and this is a part. They said, assume the population variances are equal. What are they saying? They are saying population standard deviations are equal. But like I already explained in another video, someone's saying that, hey, these two things are equal. Like, for example, like Sue's age and Samantha's age are equal. That doesn't really say how old we are, right? So that's not really giving us population variance or population standard deviation. So here we're going with the case that population standard deviations are unknown. So guess what we open up? T-stat. Open up T-stat, do toSample, and we have summary given to us. So go right here. Now let's type everything in. So sample 1, the first sample, the crabs from location A, the mean was 198, standard deviation was 38. Sample size was only 13, but they did mention population was normal, did they? I hope they did. I hope they mentioned that. Alright, sample mean for sample 2 was what? 189, and the sample standard deviation was 43, and the sample size was 9. Alright, the question is, should we pull variances, yes or no? Well, when the population variances are assumed to be equal, yes, you have to pull variances. So please click on pull variances. And what are we assuming? What are we testing? That mu1 minus mu2 is less than or equal to 0 for the null hypothesis. But for the alternative, you're going to have to assume that mu1 minus mu2 is greater than 0. So if you do that, here is that standardized test statistic for mu1 minus mu2. It came out to be 0.518. And oh, whoopsie, what was that? Oh no, I lost it all. Alright. I don't know what I hit. Let me see. If they didn't change the numbers around, I hope this is the same problem. So, oh no, where's the right stack crunch? I did too many problems today. What was the number? I forgot. Alright, I'm gonna have to do this again. Stat, tstat, too simple with summary. And I typed in what? 198, 38, 13, 189, 33, and 9. Pull variance. My browser just closed, I think. That's why I have to retype all these in again. Alright. But that's it. That is a standardized test statistics. So I'm going to have to round that up to 8 over there. And let's go on. The p-value is 0.3051. It's too big. It's way too big. Look, compared to the 10%, 30% is way too big. We're going to have to say we failed to reject. Whenever the p-value is greater than the alpha level, you failed to reject. We don't have any evidence. There isn't evidence at the 10% level of significance to support the researcher's claim. Honestly, I really didn't care about reading this part. All I know is that when you fail to reject, we just have no evidence. So when it comes down to p-values, we want it to be small, because small p-value is strong evidence against the null hypothesis. So that's how you can do question number 15 on Module 7 homework.